So I wanted to go over this warm-up question because we did look at these velocity time graphs yesterday, but that's the first time we've really looked at them, and I want to make sure that we understand how to answer questions about VT graphs just as well as we do about XT graphs. And so if you look up here, it says use the VT graph to answer the questions that follow. We've got two questions, one of them about the total distance traveled by the object, the other comparing that to its displacement. So let's talk about how we find total distance again. Does anybody remember from yesterday how we find the distance traveled from a VT graph? Because we did this yesterday. What do you think? No? Okay.
I think I might be wrong, but like just take the distance traveled times the time it took and then add it all together.
Yeah, distance traveled times the time it took. I mean, that's what you're doing, but by doing that, you're basically finding the area of the rectangles in this case that are formed by the graph. And so if you look, you're going to be first looking at the area of this rectangle down here. When you travel -9 meters per second for 5 seconds, you're going to go 45 meters. You're going to go backwards 45 meters, but if I'm looking at distance, I don't care that it's backwards. It's 45 meters. That's the area of this rectangle. Okay, and then you're going to go 9 meters in the other direction. Sorry, 9 meters per second in the other direction, so forward for 5 more seconds. So then that's going to be an additional 45. And then you go 3 meters per second for 5 seconds. So 3 times 5 is 15. That's the area of this block right here. So 45 plus 45 is 90, plus 15 more is 105 meters. That would be your distance traveled. Okay, now again, distance is scalar, so I didn't care that the first 45 were backwards and the rest of it was forward. It didn't matter because you just add those pieces together. However, when you are finding displacement, you don't do that because displacement is a vector quantity and it matters that this part's backwards and this part's forward. In fact, when you go backward 45 meters and then forward 45 meters, you end up back where you started. Okay, that part cancels out. And so the only part that would count for your displacement would be this 15 meters right here that is represented by this block on the grid, the area of that rectangle. And so your displacement's only 15. And that answers the second question, which is greater, distance or displacement. Your distance will always be greater than or equal to your displacement, and in this case it is greater than. Okay, it would have been equal to if all of the motion was in the same direction. But because I had backwards and forward, well, now I have to cancel some of that out whenever I'm looking at my displacement because, again, if you end up back where you started or if you backtrack or whatever, you end up having to add that negative here and then this part's positive. So again, which is greater? Again, distance is greater because this person or object or whatever it was went backward and then forward. And so they canceled out some of that displacement. They didn't end up as far away from their starting point as they could have if they had just gone in one direction. Okay, does anybody have a question about this warm-up? So we did this yesterday, but again, it's a good example to copy down into your notes. Again, your area is always between the x-axis and your graph. So wherever the graph is, so down here it's area going down, here it's area above, okay, the x-axis, but it's between that line and the x-axis. All right, so it said this on the previous slide, but it says it here too. Today you're going to be working on the assignment 104 Mixed Practice CFU. I'm going to ask you to work by yourself on this one. In the previous ones I said you could talk to your neighbor, but I'm going to ask you to do this by yourself as much as you are able to. However, you can use your notes if you wish, so if you did take notes, you are welcome to have those out and you may refer to them. I'm going to give you 25 minutes to work on this in class today. You don't have to turn it in if you're not finished at the end of that time, but we are going to stop after 25 minutes because there is something else that we need to talk about, and that is your first RA. So I'm going to set a timer for 25 minutes. You are going to find this assignment in Schoology. In fact, if you go to Schoology, it is going to be found here. I'll show you. right here, Mixed Practice CFU. You're going to type your ID in. It's going to give you your link. So you can go ahead and open that up and get started. It is in a Google form. And then when that timer goes off, I'm going to ask you to stop regardless of whether you're done or not, so that we can talk about the RA. Okay, so go ahead and get started. If you would like a calculator, you may get one from the back of the room. You may have out paper. In fact, I would strongly encourage you to have out paper so that you can work out any math or do anything that you need to sketch out on your page. If you have questions, let me know, but otherwise, go ahead and get to work.